Hello and welcome. My name is Moritz Eckert, and together we're now gonna deploy and scale an application in a Constellation cluster. So in here you see my terminal environment. I've already created a Constellation cluster, in this case on Azure Cloud. It has Kubernetes version, let's actually check the config file. It has Kubernetes version 1.26. And it consists of, let me export this admin conf, export, and then I can say kubectl get nodes. It consists of 3 nodes, in this case 1 control plane, 2 worker nodes. And what we want to do now is deploy an application, expose it via a load balancing service, and then scale it. So in my Azure resource group, for this cluster, I can see that there is my virtual machine scale sets. I can also see there is already a load balancer that basically exposes and balances the Kubernetes API server. In this case, we just have 1 control plane node, but if you would scale that up, it would balance between them. And if you go to our documentation, under examples, there is the emoji voto section. That's an application created by the folks from Bouillon, from Linkerd. A simple microservice demo application. So let's deploy that application in our cluster using their deployment files. So it created the deployment, the services, and the namespace. We can say kubectl get all -n emoji voto, and we will see all the resources in our Kubernetes cluster. We can see the pods are already running. We see the service, and there's one service called the web service, which is essentially the front end to this application. It's currently a cluster API service, so it means it's not exposed. So let's go ahead and expose that using a load balancer service. And what you would normally do in Kubernetes is turn that cluster IP service into a load balancer service. You can also use an nginx or some other ingress controller to put in front, but let's keep it simple here and just turn that into a load balancer service. So let's say edit service, web service, and we say this should be a load balancer, and we want this to be exposed on port 80. And if we now say kubectl get service in the namespace emoji voto, we will see this is now a load balancer service, and it's waiting for an external IP. Essentially, if we go back to our cloud portal, we see there's a new public IP address created. And if we would go into the load balancer service, you would see there would be a new load balancer rule being created here for load balancing that IP to that service. So this will probably take a bit of time until the external IP is attached. No, there it is. And we can now copy that external IP, and we should be able to reach that at port 80. And in fact, here it is. Here's our app, and we can now vote for our favorite emoji. Let's say this one here. And there's a bot running, creating votes to create some traffic in the app, so we see more votes here. Well, that's simply how we expose that service. And now let's say there's a lot of people hammering that service. So what we need is we need to scale that application. And not only do we need to scale that application, also our cluster, just consisting of 3 nodes, is not able to is not powerful enough for this enormous load. So we want to also enable auto scaling for our cluster. So let's first enable auto-scaling for the cluster. If we go into the documentation, under workflows, you see this page called Scale Your Cluster, and explains how you can enable auto-scaling for your cluster. Let's copy the first command to get the scale group for the scale groups in our cluster. And there is one worker scale group that we are able to scale called this one here. So let's copy that. And if we go back, the steps for enabling now auto-scaling for the scale groups are, first let's set this to that one here. And then we copy this command that modifies the enables the auto scaling for that scale group. And now we should see that auto scaling is enabled for that scale group. All right, and now let's scale up our deployment so that we basically trigger the auto scaling of our cluster. So let's say kubectl. Let's first get the deployment in, let's first get the deployment. Yeah, let's say we want to scale up the emojis, the emoji deployment. So let's say kubectl minus n emoji voto scale scale deployment emoji minus replicas, and I don't know, let's set this to 200 or something. And what will happen now is that a bunch of steps need to be triggered. First of all, it tries to provision all of these replicas on the existing nodes. At one point it will hit the limits, and the horizontal auto scaling or the autoscaler service here will notice that there's pods that are not able to be scheduled, and it will trigger a cluster autoscaling process that will then use the Cloud Controller Manager to talk to Azure to create more replicas of that worker scale group, and these will then be provisioned by Azure, booting our image. They will connect to the Constellation control plane, which will then be authenticated using remote attestation procedure and then joined to our cluster. So let's wait until this process is completed and we can see another node popping up in our cluster. Okay, so now we can see we have a bunch of more nodes here. We can also go to the Azure portal. If we go to the worker node scale set, we go to instances, we can see them here. So let's see what the deployment looks like. Yeah, it's already almost up to the desired 200 instances with a bunch of nodes. So of course now we can do vice versa. We can say now the load goes down. We can simulate that by now scaling down our deployment again, and we will see those nodes disappear again. All right, so what we've seen is we deployed an application in a Constellation cluster, which is just deploying an application in any other Kubernetes cluster. We exposed that using a load balancer service, using layer 4 load balancing, so using with HTTPS, the connections terminate inside our cluster. So even though it's a load balancer provisioned by Azure, there's no man-in-the-middle attack possible here. And then we scaled up that deployment, simulating some kind of load peak and using cluster auto scaling to provide the necessary Kubernetes resources for that scaling event to be able to happen. And that's it. Thank you very much for watching. I'll see you in the next video.